Hi, my name is Ethan Zipsel. This is the University of Akron, car number 264's accumulator video. So we're going to kind of start by just giving a cursory look at the accumulator box as a whole. So coming around here, you can see that we have our high voltage stickers on all faces of the accumulator. And also by looking on top here, you can see we have high voltage always energized. And likewise, that is also on the sides of the accumulator as well. So after this, we'll cut around to some more in-depth pictures of the accumulator and show the rest of it. Our accumulator has two PCBs featuring both GLV and tractive system circuits. Here's a look at our BMS board. You can see that we have a distance of 6 millimeters from low voltage to high voltage on this board. And on our high voltage board, you can see the smallest distance is 7 millimeters roughly, and this goes all the way down the board. And over here, you can see we have a larger gap of 10 millimeters. And then taking a look at our PCB, as that distance is not conform to rules, we have conformal coded those areas on the high voltage board. And you can see that again over here on the low voltage board. So now onto our high current path, we have our negative and our positive here. So right now we are having the electronics compartment separate, so that way I don't have to do any high voltage precautions. So you can see that we have positive locking on all of our bolts with these tab locks, going through a fuse here, and tab locks here and here again. And these go down into our connector here that goes out to the vehicle. And our only soldering here is these four here. This is not in our high current path. This is our pre-charge and indicator light circuitry. So this can be soldered since it's not in the high current path. You can see that there where it is soldered to the bus bars at all those points. We have a lock nut here since this is an OEM component for our e-meter. And then below our two IRs, we also have patch bolts pictured here, and that's it. Here's a look at the high current path of our battery segments. You can see starting on the negative side, we have tab locks here, and then on the plug connection, we have a locking nut on the bottom. You can see that this locked connection continues for all of them, and then we have a copper bar underneath this that goes under our segment. You can see that over here. Likewise, these bolted connections are also positively locked going all the way up. And this configuration is repeated across all 6 segments. Now onto our GLV and tractive system wire separation. The only 2 real points where these wires come in close contact with each other are right here at our e-meter terminal, where at the shortest point, we have a distance of about 20 millimeters, which meets rules requirements. And also coming back here, our connector that goes to our IMD that's mounted on our lid is in close proximity to our tractive system plus connection. Now this is covered in heat shrink, which is an insulating barrier. And when it's rested, it is far enough away to where that won't be a concern for rules legality. Looking at the internals of our electronics compartment, you can see that the poles of our accumulator stack are insulated from the walls through Formex and the 3D print holding up. Additionally, you can see our high voltage fuse here. We only have one in our accumulator. Furthermore, our high voltage always energized connections are coming in here, and they get switched at the airs here and here. There is no high voltage leaving the accumulator aside from our high voltage connector down here. And that can only be transferred by switching the airs on and conducting through these 2 paths through our energy meter and out. Additionally, the fuse and the IRs are isolated from the rest of the accumulator via the Formex on it, and additionally, this being a removable compartment with an aluminum divider from the rest of our accumulator housing all of our battery segments. All right, now on to the maintenance plug section. So we're going to start over here by taking a look at our maintenance plugs. So you can see that these are all configured in a unique configuration. So I can't, for instance, grab this one and plug it in over here because we have zip ties locking these maintenance plugs in place. Furthermore, I can quickly demonstrate here that we can remove these without the use of a tool. So click it in place, press in, remove it. And additionally, you can see that the surface of these maintenance plugs are entirely covered in heat shrink. So when you're pulling and removing them, you're not grabbing potentially high voltage while you're installing that. So yeah.
Recording.
All right, and another quick comment about maintenance plug installations. When we plug our electronics compartment onto our segment container, you can see that we have maintenance plugs going through on the bottom that connect here and here. You can't install these backwards because of the way that the plug configuration is. Right, you're this way on the thing, and you're not actually physically able to reach the plugs on both sides. Here's the look at the internals of our segment compartment of our accumulator. You can see that every segment is separated by electrically and fire resistant materials. You can see our Formex here glued on every wall of the accumulator. This is also true of the top lid as well. You can see our Formex applied here. Our indicator light is fixed on the front of the accumulator. We can see that it is connected to our high voltage PCB here. So this uses a isolated flyback converter here to convert our high voltage source into low voltage. Of course it's isolated, and then that wires around to the front. So our light is labeled high voltage present, and as all of the systems for it are inside of the accumulator container, this will function when removed from the vehicle. Here's a look at our high voltage accumulator container connector. Right here, we can see that we have HV plus, HV minus, our cable shielding here, as well as our 2 interlock pins. Additionally, we have our energy meter receptacle in our accumulator as well. We can see our 2 interlock pins here in blue. You can see that these get routed into our low voltage harness, and that is in our shutdown loop here. Here is a look at our accumulator charging cart. You can see that our tractive system cabling is orange, starting at the charger and entering and exiting our breakout box. This box houses our TSMP resistors, our discharge resistor, our charging fuse, and our AC breaker. You can see our charging fuse there, our breaker down there, and up in the front you can see our TSMPs, which are labeled HV plus, HV minus, and ground.